Hello, my name is Zane. I'm performing experiment number 2 for Chem 1412, section 62430. Today we are doing a lab factors affecting reaction rates. I have everything set up right here. So the overview is we're going to look at the different factors affecting the rate of the iodine clock reaction. Pretty much we're going to look at 2 different things and see how fast or how slow they affect the reaction rate. The subject area of chemistry that examines the speed or rates of reaction is called chemical kinetics. This seeks to understand the factors that control reaction rates. The fundamental concept of chemical kinetics is collision theory, and according to this theory, reactant molecules must collide with enough force to achieve activation energy before a reaction can occur. And activation energy is the minimum amount of energy required to break the chemical bond. And after they continuously collide, and however, only these collisions that meet or exceed the required activation energy, and those that collide, they collide in a favorable orientation, which will form new chemical bonds. So there are a lot of different things that go into place whenever you're doing the iodine clock experiment. The different temperatures, the different concentrations, the physical state of the matter. All these things are all very important, and they all affect the rate of the reaction. Some can either slow it down, and some can either make it a lot faster. So that's pretty much what a catalyst is. A catalyst is a substance that increases the rate of a chemical reaction, but is not chemically changed during the reaction. And there's different rate laws that you must always apply. Many reactions occur in multiple steps, and the overall rate of reaction will depend on the step that takes the longest amount of time. Okay, so there's all that, and let's get started. So the materials included in this experiment, we got the potassium iodide, hydrochloric acid, sodium thiosulfate solution, starch solution. We have the 1 ml syringe, and then we also have the test tubes and the rack. We got the 10 ml graduated cylinder. We got the thermometer. We got the plastic pipettes, plastic cups right here, and we also have the medicine cup, hydrogen peroxide, and then we got the copper sulfate. And we also have ice right here. I've already put it in this cup right here. And we got the warm water right here. And then we have the pure water right here. And for the timing, I'm gonna use my laptop. I have it open right here for the timer or a stopwatch. Okay, and I have my goggles on, my gloves on, my apron on for the safety. And we've already disinfected the table and we're good to go. Okay. So we got the first thing we're gonna do is gonna grab the 24 well plate, and we're supposed to make sure that 4 wells are vertical or across or horizontal, and the other 6 are vertical. And in the top left, it says place 8 drops of the Ki, which is the potassium iodide. So we'll start with that. 1, 2, 3, 4, 8. Add 2 drops of HCl to the Ki solution. So we got hydrochloric acid. I'm gonna add 2 drops to the same well, yeah. To the top left, and then add 4 drops of the, where'd it go? Starch, which is right here, yeah, starch. 1, 2, 3, 4. and then add 8 drops of Na2, where is that? Oh, that's the sodium thiosulfate to the Ki solution in the well. Okay, so this is all going in the top left. And this is 8. So 1, 2, 3, 4, 5, 6, and 7. Oh, one more, 8. Okay. Mix the solution by gently swirling the 24 well plate in a small circle on the table. Okay. So now we're gonna mix it a little longer. And now I'm gonna get the syringe. And we're supposed to get 0.4 of the hydrogen peroxide. We get 0.4. Okay. So 0.4, and we're going to add it to the solution. And let me start the timer, and I will show you the rest of the lab.